Welcome back to the Four Majors, the YouTube channel for your academic needs. If you happen to accidentally visit this channel or you are just new to this channel, and if you like unlimited supplies of academic related videos and tutorials for free, hit the subscribe button and click the notification bell so that you'll get notified whenever we post a new video. This will ensure that you'll have 20 years of good grades. So without further delay, let's dive into it, to the world of polynomials. Last slide, we have the ask you what if you are asked to solve for x to the 4 to the power of 4 or even higher, and that leads to the binomial expansion theorem. Okay, so what is that? So it follows the expansion, the products, the special products, but actually it would be much easier if you're going to use the Pascal's triangle. Alright, so we will see that the Pascal's triangle go in the form, yeah, you can check it on the on your left. Okay, so where's the Pascal's triangle? Yeah, it has something to do with the exponent actually. Okay, so this is the first level wherein x the power of 0 is equivalent to 1. Okay, and then what's next? So if this is 0, x to the power of 1. Okay, so if it is a binomial, okay, that's why I have put two numbers here, number 1. Okay, so this is also number 1. Okay, if it is a binomial representing x and y, okay, x and y, okay, it can be x plus y or x minus y. Okay, so their coefficient, okay, their coefficient will be 1. Okay, like x plus y is equal to 3, so there is no need to expand that, you know. But if the exponent is higher, so x to the 1, this is x to the 2. Okay, so a binomial raised to the power of 1 will always be a binomial. Okay, so hindi madadagdagan yung term niya. But we see na when we try to expand a binomial, multiply by itself, okay, that is squaring itself, a trinomial is formed. So meaning to say, we will get a trinomial here. So 3 terms. So first term, and then this is the second term, and then we have the last term. So the first and last term, its coefficient will always be 1. How about this one? How about the middle term? We add. Okay, so 1 plus 1, that's 2. And actually, in the term x plus 2, x plus a times x plus a, we see that this is equivalent to x squared plus 2ax plus a squared. Okay, so we have 1 here, we have 1 here, and then we have 2 there. So where is that? There you go. And yeah, this one, and then this one. So if we're going to continue the pattern, so what if we raise a binomial to the power of 3? Alright, so we add 1 here. Okay, we add 1 here. Okay, so it appears that they will have another term, or they will have several terms, additional of 2 more terms. Okay, for this one and this one. Okay, so what do? We add them. Add 1 plus 2, that is 3. Okay, then 1 plus 2, that is 3. And we see when we do the special products, that is x plus a raised to the power of 3, we know that the answer is x to the power of 3 plus 3ax plus 3a squared x plus a to the power of 3. So where are the coefficients? So we have 1 over here, hidden 1, and then we have the 3 over there, we have the 3 over there, and we have 1 over there. So this arrangement gives rise to the Pascal's triangle. Okay, if the Pascal's triangle holds, it must have the form 1, 1, 1, and then add them, 2, add 1, add 1, add them, 3, 3, add 1 to the side, and then add 4, that is 6, that is 4, then add 1. Okay, so now going back to the problem, what is x plus a or to the power of 4? What is that? So I can solve that by using the Pascal's triangle. So okay, so this is to the power of x to the 4th, so binomial to the power of 4. So meaning to say the first and last term are in the 4th power. Okay, so x is in the 4th power and a is in the 4th power. How about a here? Actually, this is the value of a here is a to the 0. Okay, you will see why. Okay, plus 4 times the product of a times x. And now the coefficient of x must be n minus 1. Okay, 4 times 4 minus 1, okay, times a. So because a here, the exponent of a here is 0, so the exponent of a here is 1. Okay, plus 6 times, okay, 6 times the product of x, okay, times a. Can you follow? So this is actually the 4 minus 2, okay, and to the a to the power of 2, okay, plus 4 times the product of x, so that is 4 minus 3 times a to the power of 3, plus lastly 1 times the product of a to the 4 times x to the 4 minus 4. So we simplify. This is actually x to the 4 because any number raised to 0 like a to the 0 is equivalent to 1. So that is 4 x to the power of 3 times a plus 6 times x to the power of 4 minus 2 is 2, a to the power of 2 plus 4x, okay, because 4 minus 3 is 1, x to the power of 1 is x, times a to the 3, and then plus a to the power of 4, x raised to the power of 4 minus 4 is x raised to the 0, so that will become 1. So the answer is, yeah, okay, so that's how easy it is. You just have to follow the Pascal's rule. Okay, so that leads to the binomial expansion theorem. Now we are going to discuss the binomial expansion theorem. Yeah, so we see that we can actually solve problems related to the products of the binomial using the Pascal's triangle. Now we are going to generalize the binomial expansion theorem. So we have the binomial expansion theorem. Okay, there you go. So if there is a binomial, namely a plus or minus b, okay, raised to the power of n, when we expand it, it will be of the form c of the o times a to the n times raised to 0. Alright, so that's the first term. Okay, so this constant right here is given by the Pascal's triangle. Okay, but actually there is another computation for this. Okay, I will show it in a separate video. And then c to the 1 times a to the n minus 1 times b to the 1 plus several terms. So if there are so many terms based from n, because the number of terms add 1. Okay, so the number of terms of this binomial is actually n plus 1. Okay, so meaning to say we can arrive at the last term, so that we'll have the last constant c of n times a to the power of 0 times b to the power of n. Okay, so note that the power of n decreases. So here n is in the maximum, so the highest power, and then you see in the second term the power of n is reduced by 1, and the power of b, or the second term, gain 1. Okay, and you will see on the last term that a is at the lowest, wherein a raised to 0 is 1, and then b is to the power of n, wherein b is at the maximum. Alright, so let's try to solve x plus 4 raised to the power of 4 using this theorem, the binomial expansion theorem. Alright, because you will see that there are examples like x plus 4 raised to the power of 8. So what will be the answer? And so on and so forth. Okay, so let's see. The constants are already known. If you are going to follow the Pascal's triangle, it will have 1 plus 4 plus 6 plus 4 plus 1. Where do we get that? Okay, so you can actually check the reference on your left. I'm gonna show you that we are going to arrive at the same solution. Alright, so we are going to use this coefficients, or constants. Alright, so what is the value of a and what is the value of b? So that is my a, and then that is my b. Alright, so we are going to substitute a to the n. What's the value of a? So that is x to the power of n, which is this one, 4. Alright, and then b to the power of 0. Actually, this is b to the 0. Alright, so what's the value of that? So that's 4 raised to 0, and then multiplied by this one, n minus 1. So that is x to the 4 minus 1 times b, which is 4 to the power of 1. So plus this one, 6 times x raised to the n minus 2, alright, times b squared, which is 4 to the power of 2, and then times x raised to the 4 minus 3, alright, so times b to the power of 3, which is 4 to the power of 3, plus b to the power of 4, which is 4 to the power of 4. So this is 4 to the 0 is 1, times 1 is 1, times x to the 4 is x to the 4, plus this one, that is 16, x 4 minus 1 raised to the power of 3, plus 4 times 4 is 16, times 6 is 96, x squared, plus 4 to the power of 3 is 4 times 4 times 4 times 4. That is 256x. Alright. So, and then plus, actually this is x to the 0. Alright. So that is 1 times 4 to the 4 is 256. Alright. So, using the binomial expansion theorem, we have found out that x plus 4 raised to the power of 4 is this. Actually, you can solve this using x plus 4 times x plus 4. Alright. So this is actually, according to the special products, x squared plus 8x, alright, plus 16. Then you're going to multiply it again by x plus 4. Alright. So you are going to get, alright, we can try. So that is actually, okay, you can use the binomial expansion or the, alright, so let's just try it. So this is actually x to the power of 3, okay, plus 4x squared, okay, and then this one plus 8x squared, alright, plus 32x, okay, 32x, alright, so that's it. So and then this one plus 16x plus 16 times 4, that is 64. Alright, so we solve this. X to the power of 3 plus 12x squared plus this one is 8 plus 4, so that's 48x plus 64, and then we are going to multiply it by x plus 4. Alright, that will become x to the power of 4, and then that one will become 4x to the power of 3, and so on and so forth. So the last term would be 64 times 4. Alright, you check. 64 times 4 is 16, carry 1, so that is 24 and 256. Alright, so you can see that once you expand this, you will arrive at the answer of this one. So you can try to verify if it will give you the correct answer. Okay, so if you reach the end of this video, alright, if you reach the end of this video, well, give yourselves a thumbs up. You you did well. Alright, and okay, if you want to continue, we can still continue to prove it. So there you go. You can actually check that our answer is correct. So we arrived at using the long method, we arrive at x to the 4, 16x to the 3, and then 96x squared plus 256x plus 256. So yeah, so why not use the short method, which is actually the binomial expansion. Okay, so if you happen to reach the end of the video, congratulate yourself. You really did well. Okay, so I hope that this video will help you in solving like binomial expansion to the power of 20, to the power of 30, and even the power of thousands. Yeah, so it follows the same rule. Okay? You just have to be very patient in looking for the arrangement of exponents and of the constant. Alright, so please give us a like and then share, and then click the subscribe button and click the notification bell so that you'll be notified once we posted a new video related to math. And I hope this will be of great help for you. So once again, thank you for watching. This is the 4 Majors.